see us there. Welcome to the computer security seminar. Today's speaker is Dr. Peter Mork from MITRE Corporation, and he will talk on database assurance, anomaly detection for relational databases. Peter.
Thank you. So what I'm going to talk about today is part of a much larger research project at the MITRE Corporation. The umbrella grand challenge that we're looking at is mission assurance. Basically, the idea is we know that there are adversaries inside our networks, adversaries inside our applications, adversaries inside our systems. Despite the fact that we have these adversaries all around us, we have to continue doing whatever our missions are. Some of those missions that MITRE is sponsoring may have some sort of military bend, but the mission may be to provide health care to the nation's population. When adversaries get inside those systems, we have to continue operating regardless. And the talk that I'll give today is specifically how do we keep our database systems up and running so that we have the least amount of damage when the adversaries get inside. So as a background, why am I even looking at relational databases? These things are pretty much everywhere. They're the trusty back ends to our whiz-bang applications. So at MITRE, we use a relational database back end for our internal time reporting system. So whenever we fill out our time card, it's going into an Oracle database. Transcom, the nation's tracking for, or uses databases to track troop and materiel movements throughout the world. So the Global Transportation Network and the Global Decision Support Systems both rely on relational databases. As electronic medical health record systems become available, they too rely on these databases. So anybody who's got these things, and I'm going to argue that that's pretty much everybody, they need to be worried about when their data assets become compromised. And the sorts of compromises we're talking about here are exfiltration, or an adversary trying to leak the contents of that database either to themselves or to a colleague, as well as manipulation attacks, attempts to change the contents of the database. Although in this talk I'm going to look just at exfiltration because modification or manipulation attacks are the focus of this upcoming year research. And I would advise you still use all of the regular standard database security measures. This is just that extra little bit of icing. But unfortunately, even if you are really, really good at database security, that's not everything that you need. It's really, really hard to get the configuration just right. And even if you do, you still are susceptible to insider threats. So if there are people inside the organization who know what your security configuration is, they're going to be the ones who can figure out how to get around it. Or maybe they're admin people who have a legitimate reason to get around those things. So that's an attempt at setting the stage for why relational databases are of interest. I'll spend some time motivating what sort of attacks adversaries can launch against these database systems, look at where we do our monitoring in terms of finding anomalies, look at the techniques we use for detecting that anomalous behavior, go over some experimental results, and conclude with a couple of comments on what sort of expectations we're making in order for our system actually to do what I advertise here. So first, what's the big deal? What can adversaries do with these database systems? So who here feels that they could launch a SQL injection attack? Okay, this is not a common topic. Glad I threw some stuff in. So first off, as I'm going through some caveats, the data that I'm showing, they are real data, they're real medical discharge records. However, they've already been anonymized, so that concern is taken out. The IDs and passwords that I'm showing are completely fake. We just made them up out of whole cloth. And the last thing is this application, the developer who produced it for me was instructed not to pay attention to security, just get the job done as quickly as possible in an attempt to sort of mimic the sorts of things that happen every day on real systems. So first, application works like you'd expect it to. I put in my user ID, I put in a password, and I'm able to say, see the medical record. Everything's working like it's supposed to. What is it doing behind the scenes? On the web server, there's some code that says select everything from this table called core, where ID equals some identifier that's going to be provided by the user, and the password equals something provided by the user. So when you put in your user ID and password, that gets converted into this code to be executed on the database platform. Select everything from core, where you have my ID and my password. What happens, however, when I go into that field and I put in a user ID, but a single quote followed by a semicolon and 2 dashes. In that case, I still get to see the medical record. What's going on behind the scenes? So this was, again, what the web server is doing behind the scenes. And when that code gets assembled by the web server, you get select everything from this table called core, where the ID is my ID. The single quote ends the string. The semicolon ends the command. The 2 dashes are a comment, so that last line, what I put on the last line is simply ignored because it's now a comment. As a result, I get all of the information about this user without ever having provided a password. That's bad enough, but it gets worse. We can start doing some more probing. So this first attempt, I've just put in and false. The goal is I don't want anything to be returned by the query that the web server was intending to run. Instead, I'm going to union all. I'm going to add in my own query. And first, I'll just try selecting 1. And when I attempt that, I get this error message, unable to retrieve data. This means most likely the SQL that I wrote didn't line up. When you're doing this sort of SQL injection, what comes before the union has to have the same number of return values as what comes after the union. And in my first attempt, I didn't guess correctly. So I'll just keep running a few more attempts until I find one that works. In this particular case, I had to keep adding numbers until I got up to 129. There were 129 columns being returned by the web server's query. I need to return 129 columns in my query. Now that I've done this, now I get back actual results. And I get back a couple of things. Might be a little hard to read some of the fine print. Not only do I know exactly how many columns I'm supposed to be returning in whatever query I want to run, but I'm also discovering where each one of those columns lines up on the form because I'm getting 61, meaning for the patient ID, meaning that the 61st column got placed there. Age was 3, etc. With that information, I can now do many more interesting things. So the next query that I'm going to run conveniently has exactly 129 columns that it's returning. Almost all of them are just ones because I don't care about them. The important thing is I can now ask for the name of a table from the database's system catalog. Basically, every major vendor out there supports the information schema.tables as part of its features. So this is going to work on pretty much every database platform out there. And what's going to happen is I'm going to get back the first table name. So when I run this, I scroll down the form and I find that in the place of the state postal code, I now have this information that I wanted to pull out of the system catalog, namely that the first table alphabetically is administratable role authorizations. Next, now that I've gotten the first one out, I can do the same thing and just say, give me the next one by saying, give me everything that's bigger than that one, and continuing to sort. In this manner, I can just iterate through every record in this system catalog and find out the name of every single table in the database. Once I've done that, I can do the same thing looking at columns. So there's another system catalog that tells me the names of the columns. I pick out all of the columns for a particular table, just pulling out one at a time. What does this let me do? Well, I've learned that there is a table that's called core. That seems to be an interesting one. I've determined that that table has exactly 129 columns, which corresponds to the number of columns that I know that the web application is generating, and that there's a couple of interesting columns in there, ID and password. So as the adversary, I now have a pretty good idea of what query is being produced on the server side. I'm basically able to reverse engineer what we here know as the actual web server code. What can we do with that? We can now retrieve a password. So by doing this, instead of reading through the system catalog, I'm going to pull out the password field for a particular ID. And when I run that query, I get back out the password. And it's not advisable security practice to use the same password on multiple different sites, but I'm betting that most people still do some form of that. Now that I've gotten the password here, I can now go try that login and password on a whole bunch of other systems and see what I can stumble across. It was an awful lot of work, though, to get just this one password. Here's a different interface to the same underlying database. This one lets you do sort of aggregate roll-up style queries. So you can query by gender, race, age, and what it's supposed to do is when I run the query, it tells me for this particular subset of people how many had a particular diagnosis. So there were 41 people who had the diagnosis code of 65421. I'd have to go look that up in ICD to figure out exactly what that code means. But it's supposed to be intended to be used by statisticians who are trying to get a feel for what sort of diseases are prevalent. Instead, I'm going to take that same query, and I'm now going to run it through Tamper Data, one of my favorite Firefox plugins. So when I hit search, up pops the Tamper Data pop-up.